Hello and welcome to MFM2PI, 5th unit, Trigonometry, lesson number 4, Finding Interior Angles. So far in our journey of working with trigonometry and working with triangles, we have determined how to find the side of a right angle triangle if we're given two other sides. In addition to that, we learned how to label our right angle triangle from a reference point, or a reference angle, and then how to set up primary trig ratios, the sine, the cosine, and the tangent from that particular reference angle. In today's lesson, we are going to use that as well as some prior knowledge about triangles to help us find interior angles that are unknown. So that's the objective today, is to find interior angles of a right angle triangle using the primary trig ratios, which we went over in the last lesson, as well as the sum of interior angles. And that's where we're actually going to begin, finding interior angles given particular angles. So as you know, or as you'll recall, the sum of interior angles of any triangle is 180 degrees, which means that when you take the three interior angles of any triangle and add them together, you come up with 180 degrees. And this is good for us because given two angles inside a right angle triangle, you can find the one remaining angle using the sum of interior angles. Our knowledge that the sum of the interior angles totals 180 degrees. So let's start there. Here's a triangle PLK. We are being asked to find the measure of angle K. So what is angle K going to be? So here's angle K over here. That's what we're looking for. What do we already know? Well, we already have angle P, and that's listed as 23 degrees. Now we also have, and although it's not as obvious or not as explicit, we also know that angle L will be equal to 90 degrees. So our job is to write out an equation that's going to allow us to find angle K. So I'll start. Angle K will then be equal to 180 degrees, which is the total sum of the interior angles of any triangle, minus the two angles that we do know. So minus angle P and minus angle L. So let's start filling in pieces of information that we know. We know that angle P, if we look at our triangle, is 23 degrees. And we know that angle L is going to be 90 degrees. We do this little bit of math and we should have angle K there just waiting for us. So let's type that into our calculator. 180 minus 23 degrees minus 90 degrees. That gives us a total of 67 degrees. So this is how you find one missing interior angle given two other angles. So your turn to give it a try now. Here's triangle KMZ. What I'd like you to do is hit pause in the video and you try to find angle K, the measure of angle K this time. When you've got an answer, come on back and we'll see how you did. Okay, let's have a look at this triangle now. We know that angle K is what we're looking for. We've been provided angle Z at 62 degrees as well as angle M at 90 degrees. So let's write ourselves that equation again. Angle K will be equal to 180 degrees minus angle Z and minus angle M. And now let's fill in those values that we know. Angle Z was 62 degrees and angle M was 90 degrees. And again, we type that into our calculator. 180 degrees minus 62 degrees minus 90 degrees, and that gives us 28 degrees. If you got there, congratulations. If you didn't, there will be plenty of time to practice on the self-assessment. So this method of finding one interior angle given two angles is fairly straightforward. However, sometimes we're given a mixed bag of information. And in this case, or in the case of the part B, we're going to be looking to find interior angles given sides. So we're going to use this when we are given two sides in a right angle triangle and we are looking for one interior angle. That's what we're after. Now to do this, we need to recall what we learned in the last lesson about primary trig ratios. Now there's an extended sort of explanation here in the note on how to find interior angle given side. So that's here for you. That's a reference. I'm going to talk you through it. I'm going to show you how to do it. And if you're stuck or finding what I'm saying to be not as clear as you'd like, then I would recommend using this little explanation that we've got here. But I'm going to talk you through it, and let's see if we can't make it. Okay, so here we have right angle triangle. We are given two sides and we want to find angle. Now this symbol here, this is new to us a little bit. This angle here is unknown, and that's a Greek symbol, and that Greek symbol, if you look at this side of the page over here, this Greek symbol is pronounced theta, so like theta. We often use that in math to represent unknown angles. We could just as easily use a letter, but this is a fairly common Greek symbol to use for missing angles, so that's what we're going to be using today. So we have angle theta over here that we are looking to find. How can we use these two sides to help us find it? That's a good question. Let's start by labeling all three sides of our triangle given this reference angle. So we're going to take the angle that we want to find as our reference angle. So there it is. So from my reference angle, I recognize that I have the hypotenuse, which is across from my 90 degree. And I also have my opposite side, which is across from my reference angle. So I'm going to write out a trig ratio, the three possible trig ratios that we could use here. So we've got sine of theta, which is opposite over hypotenuse, cos of theta, which is adjacent over hypotenuse, and tangent of theta, which is opposite over adjacent. Now, which one of these trig ratios should I use? Here's a little thing that I do to help me sort of figure it out if I'm not sure. I start putting little check marks underneath this SOHCAHTOA that I've written out here. So there's my SOHCAHTOA. It's going to be my guide, my helper. I'm going to look and say, okay, so I have a hypotenuse. I've been given that information. So these two guys here use hypotenuse, so I'm definitely not going to be using TOA. Sorry, TOA. What other piece of information have I been given? Well, I've been given opposite. That tells me that I should be using the sine ratio. So Ka, you're also off the table. So I'm going to start then by writing out the bare bones of my trig ratio. So I've got the sine of angle theta is equal to the opposite side over the hypotenuse. And now I'm going to start to fill in things that I know. So I don't know what theta is, but I do know that the opposite is 4 and the hypotenuse is 7. Now at this point we can do this one of two ways. Now I'm going to recommend that we kind of do this all in one step so that we don't have to do any messy rounding. So I'm going to show you how to do that. Taking the sine, so let's just quickly, before we move on, let's have a quick look up here. Taking the sine of something is a mathematical operation. And like mathematical operations, it has an opposite operation. So if I were to say, what's the opposite of adding 4? You would say subtracting 4. Or the opposite of multiplying by 10 would be dividing by 10. Or the opposite of squaring a number would be to square root that number. The opposite of taking the sine, or cos, or tan of any angle is to take the inverse sine and the inverse cos and the inverse tan. And in terms of a symbol, this is how it looks. So I'm going to write this out for us here. I'm going to say that angle theta, which is what we're after, we are going to undo it by taking the sine -1. That's how you write inverse sine of 4/7, which is the ratio that I've been given in this triangle. So angle theta will be equal to the inverse sine of 4/7. Now I'm going to type this into my calculator all at once. Lots of calculators, you'll be able to type this in a different configuration and in a different order. I'm going to recommend, I'm just going to put like a little cheater note here. I'm going to recommend that you type this first. Whoops, that should be a Y. Type this first. Meaning I should try to put this into my calculator first. So I'm going to type in 4 divided by 7 equals, and that gives me a big long number that I'm not going to write down. You should see a big long number on your calculator. And now I'm going to hit. Now on my calculator, it's second function sine. And that's going to give me an answer. What it actually gives me is 34.8499, etc. And I'm going to round that to the nearest degree. So angle theta is approximately 35 degrees, and there's my approximate sign. It's approximately 35 degrees. Now if you're having trouble getting this out of your calculator for whatever reason, come talk to me, come talk to whatever teacher's available to you, and they'll help you sort out how to use your calculator to get this done. But that's how you do it. In some calculators you would put the sine, inverse sine in first, then a bracket, then 4 divided by 7, and close the bracket and hit equals. Every calculator is a little bit different, but make sure if you can't get this out of your calculator that you go and talk to whatever teacher's around. Okay, so that's the first example. Hopefully you're feeling pretty good about it. I'm going to let you try the second example using the one I just did as a model if you're stuck. So hit pause here, try to find angle theta in the next triangle. If you get it, or you got stuck, but at least you've tried it. Come on back and we'll get through this one. Okay, let's get a look here. So here is my reference angle, theta, that I'm looking for. As with the previous example, I'm going to start by labeling the stuff that I've got. So here's my SO, my Ka, and my TOA. And I'm just going to check and see what I have. So I have, as in the other example, I have a hypotenuse. So I'm going to put some check marks here by the H's. TOA, out of luck again. And I've also been given the adjacent side this time. So I will be using the cos ratio. We're going to be using the cos ratio this time to work this triangle. So the cosine of angle theta is equal to the adjacent side over the hypotenuse. Now I'm going to start to fill things in. My adjacent side is 21. Cos of theta equals 21 over 24. And as we did last time, angle theta will be equal to the inverse of cos. Think of taking the cos of an angle as something that needs to be undone. Its opposite operation of taking the cos of something is taking the cos inverse of, in this case, 21 over 24. And we're going to type this bad boy into our calculator and see what we get. So as I said on my calculator, I'm going to type in 21 divided by 24, and that gives me a fairly small number actually, 0.875, and I'm going to take the inverse cos of that number. And it gives me 28.955, so I'm going to round that to approximately 29 degrees. So this is how you find interior angles in a right angle triangle when you're given two angles, use the sum of interior angles, or when you're given just sides, in which case you're going to use your primary trig ratios. Please reach out to your teachers or support workers if you are having trouble figuring out how to get these numbers out of your calculator. Other than that, good luck on the self-assessment and the mastery test, and we'll see you in lesson number 5.